So the agenda of today's session is to make you aware of how neural networks is different from machine learning and what made its importance, and at the end how we can build a simple neural network. I hope my voice is fine from my end. Please check from your end also. Everyone is saying yes. Yep. So in today's session, we'll see why this term neural network has been rose into importance and why deep learning has got its very much importance, and how why neurons are related and how neural network and what are the functions. We can see all those things. So that's what we are going to see in today's session. So can anyone say, what do you even heard about deep learning? What do you mean by deep learning? Can anyone? So that I can start the session. What do you mean by deep learning? Any? Wow, it's a simple answer. Subset of machine learning or implementation. Yes. So basically, let me make it clear. I'll start from the basic thing. So we humans have natural intelligence, right? It is only possible with the help of what is the body part which helps us? Yes, obviously brain, right? So that is the amazing body part which is about 3 pounds of grams, 3 pounds, not sorry, 3 pounds, which does all the functionalities in the human body, right? So with that 3 pound body part, see, we are able to speak, we are able to talk, we are able to walk, we are able to keep memory, we can able to look at things, we can able to recognize people. Even a small kid, when he's trained with the same kind of data, is able to learn. So that is the mysterious thing. Even any scientist is still working towards how is that capability for a brain, because we human beings differ from all other animals with the highest amount of memory we can store, and how we and whales, and how is the difference between ourselves towards, we show the emotions towards animals, right? We show emotions towards dogs and they try to respond. How is that possible? And even they cannot communicate, but through their gestures we can understand, right? So that is natural intelligence, whatever our brain does from the childhood. Even our memory is into something like three simple terms, which is short-term memory, long-term memory, and skill memory. So when I tell that is short-term memory, that means short-term memory is simple, something like whenever we try to remember for a short amount of time, something like, yes. So short-term memory is something like when we try to remember for a short amount of time. Let me make it clear how that is segregated, because short-term memory is something like when we try to make sure that we try to remember for a short period of time, right? If I tell my phone number within this webinar, if you are interested about noticing it, then you can try to remember. If I try to tell my mobile number, and if you're interested, then you try to remember, right? So that's how we make use of short term. So if I tell about long-term memory, that means our brain tries to recognize or make some patterns about the data from childhood. We remember our facts, right? The thing happened in our 10th class, or the thing happened during our childhood. We try to remember those things because those things are pretty much simple when I talk about this AI, which we can see on the screen. I'll relate this thing. And when we go about skill memory, see, short-term memory, long-term memory, skill memory. These three are different, because when I tell about short-term memory, that is something like for a short amount of time. When I go for long-term memory, I can feel something like I can remember the facts. I can have my parents' memories. Even when I'm sleeping, I can dream, right? You get some dreams. Everything is stored, and you can have some times of deja vu. That means you experience the situation happened previously. It's not we are talking about myths or facts or nothing about biology. That thing is related to deep learning, because when we try to when we try to make our interest towards artificial intelligence, it is simple like we are trying to make machines mimic the humans, because a human cannot create another human. Only God is having capability to create human beings. We can only try to mimic humans with the help of the knowledge, right? So if I talk about the long-term memory, same as I said, memories and bikes. And the final thing is skill memory. See, you have the skill to ride bikes, you have the skill to ride cars, and I may be having skill at good at swimming, or I may be having skill at martial arts. Every person has individual skills. That is the reason knowledge is different, intelligence is different. That is how our brain is having this main part, something like cerebrum, cerebellum. That is how it is segregated, and based on the lobes we have the vision capacity, we have creativity. These all things are segregated, and in the brain functionalities we have the main cells called as neurons. You believe it or not, our entire brain has nearly 80 billion neurons. See, 1 billion is 100 crores. If I say 80 billion, how can that be? So each neuron will transmit information from from one cell to another cell. That means if you're trying to listen to my voice, that means your brain is telling that, okay, you should hear this voice. If you're interesting, you'll hear. You are seeing at something. Now you're seeing in your mobile or laptop, you're talking with someone, you're playing some games. Every activity, that is with the help of human intelligence, because neurons will generate electrical signals. Something like, if for example, you can see electrical wiring in your home, which consists of series of wires, where what does that, what happens in electric wire? You cannot see the power, right? Something like the dialogue in Race Gurra movie. You cannot see the power, but the current flows in it. In the same way, in the same way, neurons will try to impulse electrical signals and chemical signals to perform any activity. So why do I need to tell those things? Because if you see the slide, you can see AI. Basically, artificial intelligence is nothing but trying to mimic human intelligence. When I try to train a machine, that machine can be a computer or a laptop or anything, because I'm trying to talk only about the type of data. That can be numbers, images, or text. Yes, so that kind of data, I would like to make sure it should be automated. So that's where the subset comes into picture. Machine learning, these are all applications of machine learning, because machine learning is different from programming. Programming is input, processing, output. But machine learning is input, training and testing. The output is knowledge, because it learns from the data, and from the future cases, whenever we have some kind of same kind of scenario or similar type of data, our model will be able to understand. That's how we have the differences. And you can see all these kind of fields relates to AI. Artificial, which is not real, intelligence will try to handle in particular situations, because knowledge is different, intelligence is different. Whatever we speak, whatever we see, if we try to work on speech recognition system, that will be task of natural language processing, where you can see Alexa, okay Google, Siri, these are all speech assistants, right? If you try to use vision, so you have Apple Face ID, you have face unlock. That's how it is able to recognize your CCTV footage will having to monitor the system, so that how effective they can do. So that is the reason, if you see AI, which can sense or reason, which can act and adopt. Machine learning, it is a subset of AI which performs and how it can improve from the previous data over time and time. Deep learning is obviously a subset of machine learning. For simple, I can say the name deep learning has been framed with the simple logic. If you see the word deep in it, we are trying to explore to the number of layers very deeper. In the same way, how our brain will try to pass information from one neuron to every neuron, so that that activity has to happen. If you want to sleep, your brain will function, your brain will activate. If you are getting some headache, your brain will try to that means you're facing some disturbances within your body, because some kind of cells are not responding properly. If you're getting cough and cold, your body, something like antigens are entered into your body, and your body is unable to fight. Yes, so that's how this word deep in deep learning refers to the number of layers through which the data is transformed. That's the reason the word deep learning has been framed. So if you see here a famous quotation, which I always love to share with everyone who am out talking about the research. So the differences between machine learning and deep learning is, it is something like, I'll give you a simple example. Machine learning is something like, whenever you teach a kid that if you show a dog, it will bark, right? If you show a cat, that will do some different sound as meow. So then kid will understand that, okay, in his lifetime, he can say that whenever a creature is barking, that is dog. Whenever a creature is making something like meow sound, that is cat. Something like his brain is trained with the data. That is a simple example of machine learning. If you go for deep learning, the kid cannot tell which breed of dog it is, right? Whether it is German Shepherd or Labrador or Pug or which kind of breed. So when I say machine learning, your brain is able to segregate the difference between cat and dog. When you go for deep learning, your brain cannot segregate until and unless you have the knowledge of what kind of breed it is, whether it is a cat or dog or something like which pattern of human beings these are, which kind of face it is. So machine learning, it can classify between dog and cat, but for deep learning, it will clearly segregate what kind of breed it is based upon the previous trained data. Because if you are good at technical things, if you are good at gadgets, if I ask about what is the best mobile, you tell me the features, you tell me the processor, you tell me about the megapixels and everything, because you are good at that thing. If I ask another kid who is good at bikes, he'll tell those things, right? So that is how you can see a famous quote. Probably this was given by Andrew Ng, which I like every time to share with everyone. So that is something like, AI is akin, that is similar to building a rocket ship. You know, rocket ship, right? That will be going to supply fuel to the space stations. So it is similar to building a rocket ship. You need huge engine. You can see rocket ships in Google that will be of very huge size. Even Tesla is building it, and NASA has, even ISRO has. It is similar to building a rocket ship where you need huge amount of engine and lot of fuel. Suppose if you have a large engine and tiny amount of fuel, what will happen? If you're having large amount of fuel, you can see, and tiny amount of fuel, you cannot make it to orbit, right? Your rocket ship will not go into the orbit. Okay, if you're having high amount of fuel and tiny engine, your rocket ship will not take a lift because it should have better engine. So to build a rocket, you need a huge engine and a lot of fuel. In the same way, to build a better model, you should have a proper cleansed data. Proper data and a clean data, which is not at all present in the real world. That's how this deep learning has come into picture when passed in 2006 itself. But now why every company is using something like Google uses, for Google images, you try to segregate the images for classification of images, and YouTube videos. Why do they use deep learning neural networks? Because they try to make sure that the data people used to search is the best amount of data, and they should get the better result. So that is how the clear segregation between artificial intelligence, because machine learning, deep learning, computer vision, natural language processing, these are all subfields of AI. Right. So that is about the history of the thing and how the things are, because you should have pretty much difference between data science and AI, and machine learning and deep learning. So deep learning is nothing but where you try to build a neural network, where you try to build an intelligent brain, something like, you can think in that way. For machine learning, without the capability of being trained, it should learn. So the more data you feed, the more it learns. So let's go to the implementation part. Before that, let's see some technical terms. As I have already explained about the neurons concept, see how does, in 2006, the famous scientist named Geoffrey Hinton, he is the one who has coined the word deep learning. So let me make it clear. See, every system will have, your system will see, basically we use Windows operating system, right? So with the Intel processor, we have default of 2 GB graphic card. Yes, some of you may be using NVIDIA graphic cards, high-end systems. So then when the term deep learning came into existence, we need to have the high-end processing system, so that whatever the data we are getting, it should be trained within more number of layers so that we get the perfect output. Instead of giving out the trained and tested data, we should get a perfect output, so that your system should need huge amount of processing. Then there came the concept of graphical processing unit. That is the reason, if you watch out video editing guys or the people who are working towards data analytics or data science, they use high-end laptops or high-end desktops, because the model should run with high-end processing, because your CPU cannot CPU cannot take. See, if you see the example of the Zoho, which we have started the webinar, it is unable, the server is unable to take the number of hits. So it made the bug in the audio, so it cannot rectify. Probably that will be rectified for the next thing. That's how the bugs come. We cannot say at what time the things happen, because that is artificial, right? We humans will get diseases. Those things will get something like bugs. So whenever we talk about this biological inspiration, this purely came from how human is able to think, how human is able to see, and how human can sense, and how human can understand, how is able to recognize. See, once I always share this thing, because you take a best deep learning model, or if you take an outcome of AI, I always tell the example of Sophia. And can I know how many of you have watched a movie called as Chappie? Chappie. Chappie. If you have some time, do watch it. That is the perfect example of how a machine can mimic human intelligence. Did anyone watch Chappie? Yes. That's a superb movie where you can understand how human memory is being transferred. There you can see that the memory is being transferred from man to machine, that is with the help of brain computer interface, because that field is still working it out. So that is how you try to watch. The movie name is Chappie. It's a splendid movie, because if you are having interest towards this kind of field, then you should be updated with daily things, because our brain consists of nearly 100 billions of neurons, and you can see some analysis over there. The size is much smaller compared to the silicon logic gate which we use in electronic devices. So in that movie you can see the memory is being transferred from man to a machine, so that it behaves as a small kid. You see a small kid who is of one age, 1 year guy. He tries to speak, he tries to walk, right? He speaks the words in a very fluent man. He speaks the words in a very something like, I cannot tell that in an English way. You understood, right? The toddler, a 1 year guy, he'll try to mimic the parents. He try to laugh at the jokes. He may not understand the terminology, but he try to understand how mother or father is trying to convince him. If he's having any kind of hungriness, he'll try to cry. If he has some pain, he'll respond with some kind of emotion. So I can say simple example, we can relate. It's not something like Ex Machina, the things will happen in a different way. Whatever I'm trying to convey is, you relate something like the outcome of a deep learning or the outcome of AI will be something like a small kid learning stage wise, how he is trying to improve his knowledge. So that is how these are the some analysis where we have made about the human brain, because human brain plays a very key role, and based on this biological neuron, as our neuron will have, basically you can see the neuron symbol. I mean how the body neuron, because if you try to watch our own body kind of parts, you can see the nervous system and circulatory system. We cannot face it, because the outer part is only skin. So our neuron is mainly capable for transmitting information from dendrites, which is something like which takes the input signal, and soma is the CPU part which processes the information. It processes through the axon, and it talks to another neuron with synapse, because this is how. So you can compare a neural network with the help of a biological neuron, because the concept has been generated with the help of same biological neuron. We replace this dendrites, soma, axon and synapse with the cells, input layer, hidden layer and output layer. That's where the concept came from, y is equal to mx plus c. That is the reason when I'm talking about the machine learning kind of stuff, or when I talk about AI, it all originated from statistics. because whenever the scientists used to work, probably 1940s itself, there was no technology and all the things. How do they relate that AI is going to change the future? I said about Alan Turing, right? He was about 1940s and 1950s. He said AI will come up in the further generation, and how people are able to cope it up, whether that can be in a positive words. That's how we replicate our biological neuron with artificial neuron, because the concept came from that itself. See, if you're, why I'm talking about this thing is nothing but, yes, I'll relate how it is equal to y equal to mx plus c, because you need to understand the basic part, how our body is working it out, and then we can relate that thing to an artificial neuron. You can see, as I said, soma is the CPU-like structure which is for processing the information taken by the outer layer dendroids, where it collects information from the other neurons, and it will process the information through the part called as, you can see the figure here, axon. It transmits the output of neuron, and synapse is nothing but a communicating part. So these terms play a very key role in biological neuron about the functioning, and the same terms are replicated with artificial neuron, where artificial neural network will be formed. You can see I have gave the difference, the cell nucleus or soma, because nucleus is the center part of an atom. We have studied in our childhood, and the same soma is nothing but the number of nodes. Dendrites are input functions, synapse is weights. What are the weights we are trying to add to a network, and how that connection is made from input to output. You can see that in recognition of handwritten digits or images, face detection, emotions. How is that formed? Because we try to mimic emotions. How we mimic emotions? Because we have been trained with that. Our father used to smile at us, so that we understand that, okay, this pattern is something like smiling. We understand that. In the same way, we should train the data in kind of layers. So we are going to take a part of basically loading handwritten digits, and we'll build a neural network, and we'll find out the accuracy how that is being formed. So if you are capable of making your relation towards your biological neuron, then only the deep learning part will get more interesting. Other than that, it looks like pretty mathematical terms, because the term has been coined previously, some 1990s itself, statistics. But when technology emerged, people try to replicate the term with data science. If we kind about the service, and if we say about the product, that is artificial intelligence, where you try to mimic the intelligence from humans to machines. You can see every neuron holds an internal state called as activation signal. See, someone asked me how we can relate y is equal to mx plus c, because what do you mean by y is equal to mx plus c? That is a straight line equation, right? You take up x as the y is dependent on x is the independent factor. If I take about the example of agriculture or e-commerce or financial sector, see, due to this present situation, if I talk about COVID situation, what does that mean? You can see that stocks are decreasing, and everywhere we can see economic crisis. That means we have been thrown back 2 years backside due to this present situation. See, even now AI is trying to work out how to make sure the business things will go on. So the simple things come from your independent variables and dependent variables. How these factors are trying to change the further crisis. That can be economic, or that can be financial, or that can be stocks or food, health sector, everything. If we have more amount of data, we can start doing with machine learning. If your data is about images, you try to work it out by building a neural network, so that you train the data. The 4 steps remain same only. The first step is collecting the data. The second step is you try to go for pre-processing the data. That is data pre-processing, data cleansing, data wrangling, and data modifications. And the next step is you try to build a model. That model can be a machine learning model, or that model can be where you try to build a neural network. because that neural network will be filled with the help of some important terminologies, which I would like to make it clear for you in today's class. Those terminologies are framed from the basic y equal to mx plus c equation itself. But we have some separate names for it, where we call it as activation function, or we call it as loss, gradient descent, and all these terminologies. Let me make it clear. So how about artificial neural network? See, we have the brain, we have the biological neurons, we are able to process the information. And if we try to mimic the same thing to our data, we try to build so many layers. And if you remember, when we are discussing about the date time module, we have used time functionality, right? Can you remember? Hope if you are in the previous webinars, we have used time functionality where we have calculated the present time from 1970 to present time, because it does not only take up the same information, we can take up the same logic for calculating any data model functionality, how much amount of time is being processed. The same terminology we use here with a word called as epoch. It is nothing but how much time has been taken for training and testing time. And we talk about activation function, we'll be talking about bias, and we'll be talking about the propagation. We'll build a neural network at the end with the help of built-in data set. That is the reason we'll only use Colab. Let me make it simple here. So this is how a model you can see. You can see the number of inputs, right? I'll make it clear with this image. You can see the number of inputs, right? Whatever your x1, x2, x3, and so on. You have this function called as summing function. If I see about y is equal to mx plus c, where y is your dependent variable, x is your independent variable, and c, what do you call it as? Intercept, right? I use the same logic here, but I try to add more number of layers so that if I try to take any images, we talk that as a convolutional neural network. If we try to train that with memory, we call that as recurrent neural networks. The basis is something like a perceptron, which is similar to your biological neuron. Artificial neuron, we call it as a perceptron. If it is multi-layers, that is called as artificial neural network. Network is nothing but connection of all neurons, right? In the same way, we try to add the number of weights towards it, and we have a summing function. This is nothing but an activation function. Why do we use this activation function? Because we try to map our input to output. That means, let me show you a simple image where you can see this, right? Yes, if you see this image, can you see an image over there which replicates the numbers? When I share the PPT, you try to understand. This is actually a GIF where you try to understand what we are giving out, the present numbers. I'm unable to share it in a slideshow. So if you see the present input, the first 784 pixel values, what are those? Because that is simply a pixel with 28 by 28 resolution, which forms as 784 layers within a image. You see, when you take up an image, see, if you try to buy mobile phones, yes, you are going to code. If you try to buy a mobile phones, if you are good at understanding the processor, you will try by seeing the processor. But if you are only about the camera functionalities, guys, you should not only look about the resolution. You should also see about how the focal length and how is the aperture and all the things. See, then basically, when I talk about pixels, it is nothing but the group of image will consist of group of pixels, right? So if I take about a number 2, you may write in different way, I may write in different way. Something like, if I write 2 in this way, I think you see my screen, right? I may write 2 in this way. You may write 2 in these many patterns, right? We humans will write different way, but our brain will able to understand in what pattern we may write, we can recognize the number. Am I correct? Yes, will you accept with me? In what pattern we may write a number, our brain will try to recognize. Even if we try to crisscross the words, our brain will recognize. How is that possible? Any guess? That is actually the biological neural network which your brain is functioning, and the same concept is being related to artificial neural network. So my main motive of the session is to make you very simple that you should relate neural networks to your brain. See, we may have different patterns. Here I have taken 28 by 28 resolution of images with, so 28 by 28 is 784. So if you see the last output, the numbers are 0 to 9. When I share the PPT, you can see that is a GIF image. So see, when I pass 2 as my input, this is my input layer, the first one. The middle layers are called as hidden layers. You can see every neuron connection. You can connect this, you can take this as a neuron, which is artificial neuron, which triggers from each patterns to every other connected part. So middle layers are called as hidden layers, and the last layer is called as your output layer. Once you pass an image 2 within it, your model should recognize the output as 2. How is that possible? Because it passes into 4 steps. Because I have defined only 2 hidden layers here, you may go with some other layers. That is the reason your GPU should be pretty good handful of processing. You should have high end of GPU. That's where we use gaming laptops, or we use high-end Mac systems, or we use high-end Dell systems for training the models, because your system cannot take the speed. It will go into hang state. It will not able to perform any operation. That is the reason for deep learning we prefer GPUs. The difference between CPU and GPU is, for central processing unit you may perform the general applications, but for graphical processing unit you go with high-end kind of applications. So the first layer is your input. You're passing some number with any image. Your middle layers are called as hidden layers. So in the first step, your pixels has been converted it into edges. Because if you write a number 2, I have shown how many ways we can write. You may be having the outer edges, right? If you see your face, your outer edges are different from your face to your mother face, because both are different. Yeah, because every human being has different edges, different face features, different edges, different fingerprints. In the same way, the first layer is the input layer, where our number has been formed into pixels, and the pixels into edges, and the edges are made into patterns. Those patterns will try to find out from the given image, and finally it will sort out which number it is. That's how the handwritten recognition is formed. We'll try to build a simple neural network, and whatever the things which we are doing today, you can do it for any kind of data set. But the thing is, you should download the data set. You'll try to train the data set first. You'll try to see the accuracy. Then you go for prediction. That is the same concept everywhere. Whether that can be a neural network or that can be anything. But the thing is, if you go for neural networks, you try to have number of hidden layers, which you cannot see with your human eye. That's where the number of epochs comes into picture. Where you try to train the model, this epoch is nothing but the number of iterations where your model is trying to take. Yes, that's how the concept of batches and all the things comes into picture. So this is the simple overview. Am I clear? Then I can go for the types of neural networks, and we'll see how the sigmoid function has been used for creating an artificial neural network. Yep, nice. So when I share the PPT, you try to see this image, that will be a GIF format. You'll understand in a better way. Because here I cannot show that in a slideshow mode. It is unable to show here, right? So when I talk about the general things, if you see here, this term is called as bias. Y is equal to mx plus c, where you term c as bias. Here I have written b as bias. Bias is nothing but where you are trying to add some weighted layers. If you see the previous image, the middle layers are called as number of weights, where you try to activate with the help of some activation function, so that it triggers the signals from edges to patterns, and these both will match, so that you'll get a final output recognizing a particular number or particular image, particular emotion, or anything. That is the reason deep learning is gaining its importance. Some kind of notes about how bias is formed. See, y equal to mx plus c. This function f is called as the activation function. We are having number of weights. The part where you try to squeeze the output from -1 to 1 or ranging anything is nothing but where you come sigmoid functions and rectilinear functions and all the things, right? So let's go to the implementation part. You try to open Colab. We'll try to see how these sigmoid functions are related to building a neural network. Open Colab. I hope everyone is similar with Colab, right? Familiar with Colab. You open Colab. Just a minute, I'll make my login. Open Colab. In the meanwhile, we don't need any data sets outside. We'll just try to train with the built-in functionalities. As I said, activation function is something like which triggers your input to the output, which is very, very important, where the most commonly used activation functions are sigmoid function, rectifier linear unit, and softmax function. If you are familiar with something like logistic regression, you might have heard the sigmoid function, which is 1 by 1 plus e power minus z, which has been derived from linear equation, right? So this activation function plays a key role when you try to map your input to output signals. If you see the previous PPT, we have had the hidden layers. What are you trying to transform from input layer to output layer, right? So let's try to implement it. What I'll do is I'll simply show how the sigmoid functions are generated, and we'll relate that thing to our frameworks, because I did not talk about any frameworks until now because we are having so many deep learning frameworks. We'll have a small glance on it and we'll proceed for this thing. Hope everyone have opened Colab. You just go ahead. If you're having any differences in my voice and screen, please let me know. We'll wind up at 8:40 today, just 10 to 15 minutes more because we have the technical issues. So let's import first NumPy as NP, because if you are familiar with NumPy, you don't know how much importance it plays a key role, because NumPy is for multi-dimensional array where you compute numerical calculations. If you see, Neuron is simple, which is something like a function that holds the value between 0 and 1. That's it. If you believe it or not, that is the simple logic. That is the reason TensorFlow has been introduced by Google in 2015. Why do people start using TensorFlow? Because we used to have Theanos and so many frameworks. But why do people use TensorFlow? Because that is from Google. We have a better developer community. We can try to train with the inbuilt modules, inbuilt libraries. We have so many things. So if you are good at NumPy, then you can relate the same thing to TensorFlow. Because in today's session, we'll be using a TensorFlow backend with the help of Keras. That is the reason I'm using only Colab. Because if I try to make it my system may work, but I cannot expect the same thing from your system. So that is the reason you can use Colab, because it will provide us nearly 12 GB of RAM and 100 GB of hard disk. That much amount of RAM we cannot expect from our end. So we'll be using Colab. So you need not install any packages here. Just let's import NumPy, and I define a function called as sigmoid function, because I want to show you how these activation functions look like. Then I can relate this thing to building a artificial neural network, because that is our main agenda of today's session. How does the things work out? So generally, I've defined a function named as sigmoid array, and what I'm trying to return the output of it. That is 1 by 1 plus e power minus z. That is the general formula for sigmoid function. If you are good at something like regression concept, then that is familiar here. Don't worry if you don't know that thing, because our next webinar itself is building a regression model, and the next one is building a classifier. If you follow our webinars, then you'll have some awareness about these things if you are fresh towards it. Because our main motive is to make your quarantine time very helpful. So how would I take exponential function with the help of NumPy array, right? So 1 plus e power minus z, I said 1 plus np dot exponential of minus x. You just return the value, it is run. I'll define some range so that I can see the output of the sigmoid function, because It is simple. It is nothing but a logistic function where your output will be ranging in the format of 0 to 1 itself. If you go for linear function, you can see, if you see my screen, what do you mean by linear function? As per your x increases, your y also increases. Yes? Am I right? This is your linear function, right? That can be increasing or decreasing. Then what about your logistic function? Because you have your output only in the format of 0 and 1. That is the difference over here. That means, what does that become? Your output becomes in this way, which becomes the sigmoid function. That means the value will be clipped between 0 to 1, because that is a classification model, right? Either your output will lie or that does not belong. That is 0 or 1. That's it. So I arrange within the interval np dot a range of, I define some values. You can define your own values. Then I make this input values into the function. So I call the function over here, and what is the input I give? In place of x, I give out numbers. Just I wanted to represent how does a sigmoid function will look like. So for that, what do? I import matplotlib.pyplot as plt. Then I define my figure and axis. How do I define? With the help of subplots, because I wanted to show you how does a sigmoid function look alike. So I'll plot it. You can give out the numbers because that is your input. And what is your function which you have defined? The help of sigmoids. I need to plot these values and I want it in the grid shape. So for that, I define grid is Boolean. Then I show the graph. That's it. Because I want to represent the sigmoid function. See, this is how your sigmoid function will be clipped. Your output will be clipped in the format of 0 to 1. See, you can see the values increasing here. This is how a sigmoid function is formed, and which forms the basis for the classification. That is the reason logistic regression plays a very key role in classification. Until and unless the random forest SVM were introduced, logistic regression was the something like king of pandas, which is the something like Ninja Turtle, which holds the entire family. But when these models came into picture, they have derived the better compatibilities. You can see that in the format of an S shape, which is continuously increasing, and either you're having some threshold value. With the threshold value, either if it lies below this case, that is, it falls into another category. If it falls into another category, you name this as a threshold parameter. That is the reason this comes under classification. This is how a sigmoid function has been taken into input, because your output will be, yes, that will be always in the shape of an S shape, because your output will be clipped in the region of 0 to 1. That means you try to squeeze your activation function within your range, where you try to make sure how your input is being into range. That is the reason when I talk about the activation functions in neural networks, it plays a very key role when you're trying to trigger your weights. Based on those weights, how your model should learn. That is the reason the majorly used activation functions are sigmoid functions, softmax function, which takes its input from sigmoid, and rectified linear unit. Yes, obviously. Normalized in the sense you try to make it in the format in the range of 0 to 1, right? That we call it from scikit-learn. The basis has formed from the regression concepts itself. Yes, this figure you can see the sigmoid curve representation. The curve ranging from, if it is above, if it is greater than 0 positive values, that is in the range of increasing. If it is in the negative values, that is decreasing. That means your output is clipped. I can draw it in a simple way. This was your linear, which has some 0 to all values. If you want output only in the format of 0 to 1, that will be clipped. This is 0 and this is 1. You cannot expect every time a linear shape, right? That is the reason that has been formed into a sigmoid curve. Yes, so that is how the thing. you are trying to plot it. Figure com axis is equal to plot dot subplots, in the sense you want to plot this in the form of axis. That is how I gave the thing. So this is a simple representation for sigmoid function, because this plays a very key role in the formation of activation functions. This was a general thing which was introduced when we are having about the neural networks. Yes, is it done? Then we'll go for the simple representation, how you can clip only the values with consistently increasing in the linear way, not in the something like exponential way. For that, we use rectifier linear unit, where your output will be clipped, which always gives the positive output. For every negative output, the value will be 0. That's what we call it as rectifier linear unit, RELU, which plays a very key role in neural networks. We'll use ReLU model, RELU, rectifier linear unit, which stands for rectifier linear units, where it takes the range of values R of X is equal, because everything relates to mathematics, and you try to understand how Y is equal to MX plus C is being formed, because if you follow the next session, you'll be able to understand why is that important. So R of X is equal to maximum, it takes in the values in the format of 0 to X. Only the positive values will be consistently increasing. That means it gives output 0 for all negative values. That means if you are getting any kind of negative weights, what does that mean? You try to squeeze the values. You'll clip the values within a range, that is 0 to 1. Otherwise, it is same as given number. That means if you are getting positive values with the help of multiplying the weights, that weights are nothing but you try to give out the difference in images. Just I'm writing comment for your sake. Now let's build a simple function with the help of rectifier linear unit, because I want to show you how pictorial it represents. You can play with the numbers by changing the values. The function is for sigmoid function, that is 1 by 1 plus e power minus x. For rectifier linear unit, that is maximum of your inputs. It ranges in the format of 0 to x. Whatever you give, it forms in the range of 0 to, because for all negative values, that is 0. The output is 0. That means for all negative values, in the sense, if you are trying to build a model for classification of images, human images and non-human images, if you try to train all the human faces and you try to train all the animal faces, your model will understand, because human face features are different and animal face features are different. Here animal face features are called as negative values, because you are trying to build a face unlock system for your mobile, not for the animals. So that's how the face recognition systems are being built. That's how Apple has been brought the Face ID for Apple 10. You try to relate the same thing to images, because everything is read in the format of images. Your something like numbers or classification of images, anything. If you try to go for stock analysis, then the number data, you try to same pre-processing will be going on, where you try to form the model of data into similar shape, that is in the format of zeros and ones, where label encoding comes into picture, because everything is related. The data is different. That can be number, text, or images, where I define the array of numbers. I take the numbers input, because numbers I gave in the previous thing. What did I give numbers? I gave it in the region of, you can print the numbers, you can see what is the output over there. These are the numbers I gave, right? So I'll try to frame a rectifier linear unit for this by applying the same input. Just I wanted to show you the representation. How does that look? PLT dot same. You're trying to plot subplots. You're dividing the axis. That's it. What you want the numbers input, and you define the rectifier linear unit, and you just give away the grid. This is simple representation. It is not involving any mathematical logic, but yeah, directly I'm using the functionalities for rectifier linear unit and for sigmoid function. See, this is how a rectifier linear unit is. If you clearly spot the difference, that is consistently increasing, same as a linear graph. You can change the numbers, you can change the interval. This rectifier linear unit will activate only the nodes which are having the positive information. That means if you're trying to build a face model or any image model, those are matching the, if there's are matching the edges, if those patterns are similar, then the node gets activated and it will combine all the layers and it will try to create the same output. That is the reason these are called as activation functions. If you try to relate this thing to real sensors, that will be understandable and you don't think this is something like out of box. This is similar to how we are trying to make sure your classification of images or digits, because this rectifier linear unit plays a very key role when you're trying to recognize the numbers or images or anything. So now what do we do is we'll try to build a simple neural network where we'll take the data set of the handwritten digits from the official MNIST data set, because that is the peculiar data set when we try to build a simple network. So you try to follow the same procedure for any kind of data set, then you'll understand how that has been got its importance, because the same process remains same. For that, we use deep learning frameworks, which are of different types. Most probably these are used. You can try it out the tanh functions. We'll use these two functions and we'll try to see, because we have the time functionalities and all the things, right? So the most widely used deep learning frameworks can be the TensorFlow, Keras, Theanos, and Microsoft frameworks and all the things. But due to the importance of the developer community, you can see TensorFlow has been gained importance, and Keras are also big, which uses the backend of the TensorFlow, where we try to frame the models. Because what do you mean by deep learning framework? Which is nothing but a library or tool where it allows to run your models. Where sklearn is nothing but it's a heart of machine learning library where you try to go for training and testing data. That is different. If you use these deep learning frameworks, they provide an interface or a library to build a model, so that your input layer, your hidden layer, and your activation layer will try to work. So for that, the famous well-known libraries are TensorFlow, Keras, and if you heard about Theanos, which is built in something, which is one of the earliest deep learning library, which is built in Python, and Keras, which is official open source network, which takes implementation of running on top of TensorFlow. That is the reason if you observe, TensorFlow and Keras will work together. So if you are trying to use in your system, you need to go for pip install, but I'm using in Colab, you need not install anything. If you want to do in your system, I can write the commands pip3 install TensorFlow. These are the commands for installing, because 3 is the Python 3 version. Sorry, TensorFlow, that is T capital and F capital. Is how you can try to install. You need not install in Colab, because in Colab it is already installed. I'm just writing for your comment purposes. If you want to install in your system, you can go ahead, because in Jupyter you don't have this, you don't have the flexibility to run, to have the packages, because deep learning frameworks are not inbuilt present in your system. So TensorFlow is the wide known one, because that is the product of the Google, where Google tries to work it to own their models, and they feed the built-in data and they give the updates. So you can trust Google, right? So this model is being consistently running from past 5 years. So I'll use my Keras model. So you need not install anything. I'll be taking the simple data sets. So from Keras.datasets, you import MNIST. You import this data set, which is inbuilt present in Keras, where MNIST stands for, which is the largest handwritten database only, where it is being, which consists of 60,000 images of training part and 10,000 images of test images, which is modified National Institute of Standards and Technology, where they have taken the data of 70,000 samples of handwritten checks, handwritten images from all over the world, and they have framed a data set so that people can start working on it. This is the well-known library where we'll try to build a neural network and we'll try to see the accuracy. It's not about prediction over here, because for prediction, you need to have the data set as loaded. So you import the models, because here the models input your input layer, your dense layer, and your activation layer. I can tell you that you can use this method for building a simple neural network and you can train them. You can directly go to the Keras official documentation where you have MNIST data set, fashion data set. You can have all those things. You can have Keras documentation, because whenever someone asks me how to learn, I can suggest only the thing is you can go with the official documentation. So you import layers, all kind of layers, and you convert your binary data into the encoded data. You convert your array data into encoded data with the help of utils. From keras.utils, you import to underscore, see, it is giving you default categorical. Within 10 minutes, we'll be able to build a simple neural network which will try to run for multiple instances of time. Yes. So once you run, you can see you may get the output as using TensorFlow backend. If you're getting that thing, don't worry about the output, because Keras uses TensorFlow as a layer, because it's a library of neural network which has lot of inbuilt hyperparameters. Yes, did you install the packages? You are installing only Keras, you are loading the data sets. If you can go to Keras official documentation, you can have the built-in data set same as sklearn. I'm using here handwritten digits data set, MNIST, Modified National Institute of Standards and Technology, where the data set has been framed by the scientists, which is the well-known one. So let's load the data sets. Training part, testing part is similar here. Train images and the labels for it. I take this as a single part, because you should load the data set, right? You'll be loading it from official Keras repository. Test images and test labels. You load the data set MNIST dot. See, you can directly give load underscore data. See, once you initialize this, if you want to directly load it from the web, you can go to MNIST data set in the web. You can go to official documentation, you can download it, but that will be of different format. So here I'm trying to make use of this. You can see the downloading information. See, downloading data from s3.amazon, because that is in the Amazon server. You can see the data set is downloaded. Yes, those are the, because it consists of 60,000 training images and 10,000 testing images. We'll train all those things and we'll test all of them with the help of our layers, and we'll try to find out the accuracy by fitting the models. Yes, is it done? Training images and testing images. Let's start building our sequential model, because this is for stacking up layers. How do you define it? You define it in the format of, just 10 more minutes, we can wind off. Network is equal to, I name some variable, network is equal to whatever the models I define, I take up it in sequential form, because step by step, you can, if you remember the previous image, you can see here suggestion, linear stack of layers, list of layers to add to the model, because I'll be adding input layer, hidden layer, output layer, because these many number of images should be trained, right? How should you recognize the number automatically? If their model is trained, then you can use this model with, by downloading the data set to your system. You can pass some images, it should be trained, and finally it should give you an output. It is not a simple output here. Now we have given out by sequential models, because we have initialized the sequence. Then because in Keras we'll be having some different types of layers, which includes the dense layer, activation layer, dropout layer, flatten layer. So the main things which we are going to use is dense layer. I can write some comment for it so that you will be able to understand. Dense layer is nothing but all the nodes are fully connected with the output layer nodes, because as I have shown in the PPT, you are having 784 pixels of images, because every image 0, 1, 2, 3 is of 28 by 28 pixels, which is 784. So all the images, so 784 layers will be transformed into hidden layers, and finally your output can see 0 to 9 number. That means only 10 layers. So for that, you define your dense layer. You add this layer, network dot add. How do you add them? You go for layers dot dense. You're initializing the dense layers. As I said, 784 pixels, and you initialize your activation function, because this is, see, you can see the suggestion over there. Dense implements the operation where you pass the function as activation. ACTIVA activation is equal to, what do I define here? I go for rectifier linear unit, because I want to squeeze my output in the format of 0 to 1 itself. If you want, you can go with sigmoid function by your use case. No issues with that. Then I define my input shape. Input underscore shape is equal to, what is the size of every image? 28 by 28, right? You define the size of the image. You close the dense layer and you close the functionality. That is for your training part, and you go for testing part and you activate the function. You can pass the same, you can copy the same information and you can paste it, because you'll be adding the layers and you can visualize it. You're adding the input layer, you're adding the hidden layer, and you'll be finding out the test output. For that, you need to give your input in the format of training images and testing images. Then finally, once your input layer for training images and testing images are added, then you define with the activation function, because your activation function will make your input signal will be converted to the output signal. So this process will remain same, where I'm trying to add my activation function as a softmax function, because it results in the format of the exponential, and I can see. So here I'm adding only 10 layers, because I cannot see all those layers. The best thing is we'll go with the generalization one. I'll add the 10 layers. And what about my activation function? My activation function is the softmax function, because the softmax function is a pretty widely used functionality to make your input layer converted into your output layer, because activation function plays a very key role. You can go for activating the training image and testing image with sigmoid function also. Then you map them with the activation function, which is a softmax function. Once these input layers are added, what you need to do, you can compile them. What does a compiler does? Which takes all the input and it results an output, right? Whenever you initialize a model, you need to compile it. This is the step where you can go for. You can compile the model where you add some optimizers. Here, these are the terms where you need to add, because these optimizers will make you how to optimize the model. The general optimizers can be stochastic gradient descent and Adam optimizers, TF optimizers. These are the general terms. So from that, I can use Adam optimizer, because gradient descent is nothing but how your data is being generated to match the output target. That is to minimize the error rate. So optimizer is nothing but to minimize your error rate. So you can see the suggestions over there how you are getting. Optimizer is equal to Adam. See, string name of optimizer, because it configures the model for training. So I use my optimizer as Adam, and I define the loss ratio as according to entropy. because entropy is nothing but the measure of impurities. We use the categorical entropy, where I try to map my input to output. Then the final thing is you need to calculate what? Accuracy. So you define your accuracy within the list so that it should note down the values. See, once you give out this step till here, just a minute, some syntax mistake. It is cross entropy, sorry, not entropy, just a typo mistake. So this step of compiling is nothing but you're trying to minimize the cost function and you're trying to minimize the loss, so that whatever the images you're trying to give as input, it should go to the 10 hidden layers based on the edges, based on the pixels that should be transformed into the edges, and the edges should be recognized it into patterns, and from those patterns you should get the output. Yes, for your purpose I'm trying to copy the 14th cell and I'm placing it in the chat box. You can do it. And the final step is compiling. Then once this is done, your neural network is successfully created, because this is the common step every beginner will need to learn. That is our main intention. You need to understand. You can combine all of them, and finally once this is done, our neural network is successfully created. Just 5 more minutes. Where you go for training part and the labeling part, then you give out the fitting to the model. That's it. Those are the steps we have left. I go for train images. Same, how you go for reshaping it, because those images should be reshaped according to the array. So dot reshape, because you have just created the skeleton. Now you should pass the values into it. So you should, because this is for the training part, as MNIST dataset will consist of 60,000 images of resolution, which each one 28 by 28. Yes, we'll share the PPT, don't worry about that thing. And again, train images for the labels, and I'm converting it into float type so that it may recognize in any format as type. Basic one, float 32. Once you have given skeleton, you are trying to give out. Why by 255? Why do you give 255? Because the maximum range of bits is 0 to 255. So that is your training images, and you can copy the same thing and you can go for the test images, because MNIST dataset will consist of 60,000 training images and 10,000 test images. So the test images are nothing but how your data has been split into test, where you can replace 60,000 with 10,000, and same you're trying to convert the type of the data into float. That's it. That is the same thing you need to do, because we have created the skeleton and now we are adding the values layers into it. I mean the input data into it. I'm copying it in the chat box. You can take it up. Now, once this is done, our next target is to train these labels, because we have trained the images, right? Now we need to train the labels to categories. Which category it should form, whether it is yes or no. If I give 5 as the number, whether it is going into the model or not, that part will come in prediction, because here we are just trying to build the skeleton and we are trying to pass the data and we are trying to fit the model into it. So just you give out the labels. Yes, you'll get you're trying to convert it into categorical. What you're converting, what are your train labels? You can go for the same thing with test labels. Same, you can convert that into categorical, because you should segregate which category that belongs. Once the network is created, you set out your labels. I'll copy this in chat box. You can see it. Then our network is created, our images are inserted. The final thing is what you do in linear, what you do in regression or machine learning, you fit the data. The same thing you can do. This is our important step where we have reached the end. What you need to fit here, you need to fit the images and you need to fit the labels. So training images, because always fitting will be done with the training data set, and I define my EPOS as only 5 sets because 5 times it should iterate. You can give out number of iterations, but if your system is of good size, then it is fine. I define my batch size as 128. That means 128 layers are to be introduced here. So I define 128 as my batch size. So batch size is equal to 128. So number of epochs, it should take 5 epochs for the calculation so that it will give you some training accuracy. Then based on that, you can see. So you can see how it is being trained. I can copy this in chat box. You can see how that is being trained. EPO 1 by 5, 60,000 images. 60,000 images. All the training images are being trained and you can see the loss. The loss is first one 20%, accuracy is 93%. For the next iteration, the loss is 7%, 0.07, and accuracy is increasing, 97%. And for the third iteration, see how the images are being trained because you are having the Colab of 3 GB, 12 GB of RAM. You can see the estimated time is very less. But if you go with your CPU, obviously you can understand how that is going to take much amount of time. You can see the final your accuracy, training accuracy as 99%. This is how you fit the data. And finally, you can check out the test accuracy with the help of the loss. How much is your loss and how much is your accuracy with the help of network dot evaluate, because you want to evaluate the accuracy. The help of test images and test labels. Always for fitting we go for the training images and training labels. For evaluation we go for the test images and test labels. If you understand the same procedure, you can go without for working out for any basic data sets. That's how you should learn. And test accuracy, and what is the test class? My string and my variable, my string and my variable. That's the final thing for test images. You can see the test images are being trained and you can see my accuracy as 98%, and my loss is very, very less, 6%. That means my entire data has been trained and tested and it is giving out the very good result. You can see I have pasted in the chat box. This is how a neural network will build, starting with how we are going to try to add layers and how your activation function is going to take, and then how you fit the data into it and how you evaluate. The next step will be how you take your this neural network model into a pickle file and how you go for prediction. You can use the same steps, but you should have a GPU. So that is the reason you can use Google Colab for your research purposes, where you can understand. This is how we have built a simple neural network where you need to go for adding layers. And once you have added the input layer, you can compile the layers with the help of optimization and you're trying to regulate the loss. And once the neural network is successfully created, we go for fitting the data. Before that, your training images and training labels. And finally, you calculate the accuracy. For this built-in data set, we got nearly 98%, but this will not happen in real cases because in real cases, your data will not be clean. That's where Google is about to take some much amount of time from past 5 years to build a better framework, TensorFlow. And from that, Keras has been come into picture, Theanos and all these libraries, cafe models, if you go for working out images for CNN models, and deep learning framework, which is built on Java, and Torch, which is developed by Facebook, Google, and Twitter, which to make building deep model very simple. Yes, if you try to follow the same procedure, then you can build a simple neural network and then you can predict new data, you should download the immerse data set and you can take up this model and you should iterate it. That's how you should go for it. For predicting the data, you can go for the iteration purpose. See, might be you have given reshape as braces closing. That's how the mistake is. Any kind of Python programs, and it is purely for Python applications, you can use Google Collaboratory for high-end processing. You need not install any packages. You should have better internet connection. Hope we have enjoyed this session also. Thanks for your cooperation, because even though the network issues we had, you were able to attend the session within no time. We have delighted for that. So thank you for your support.